versatile and most useful modern construction material. To achieve the desired structural and functional properties of hardened cement concrete, its manufacture and properties during plastic stage need to be suitably controlled and checked. The workability is the ease with which the concrete can be placed, molded, and compacted fully in its mold. More scientifically, the workability is that property of plastic concrete which determines the amount of useful internal work necessary to produce full compaction. Workability is defined as the property of plastic concrete which determines the amount of useful internal work necessary to produce full compaction of molded concrete without any segregation or bleeding. Good workability results in much better compaction and hence dense concrete with minimum air voids. From the graph, it's evident that due to lack of compaction, even 5% air voids in plastic concrete results in 33% reduction in strength. 10% air voids in plastic concrete results in 55% reduction in strength of hardened concrete. Thus, the workability of concrete in plastic stage is of utmost importance in compaction of concrete and ultimately in achieving the desired strength and other qualities of concrete. The phenomenon of workability is associated with sub-concepts of ease of flow, which indicates flow characteristics of concrete. Prevention of harshness, which indicates surface finishing characteristics. Cohesiveness, that is, prevention of segregation, which indicates homogeneity of concrete. Workable concrete mixes should not segregate. Improper handling leads to segregation. Prevention of bleeding, which shows oozing of water and cement slurry to surface. Good concrete mix should not bleed during compaction and finishing. The size, shape, texture, and grading of aggregate particles affect their surface area. Surface area per unit volume increases with the decrease in size. Crushed aggregate has more surface area compared to rounded aggregate per unit volume. Water used in making concrete lubricates the surface of aggregate. The quantity of water per unit volume affects the lubrication of aggregate particles and hence the workability. Thus, the size, shape, texture and grading of aggregate and quantity of water affect the workability of concrete. For achieving the desired workability, the quantity of water is decided on the basis of size, shape, texture and grading zone of aggregate. To achieve the desired workability, adopt suitable aggregate to cement ratio and fine aggregate to coarse aggregate ratio depending on the sand grading zone, size, shape and grading of coarse aggregate. To achieve economy in the manufacture of concrete or higher yield, the proportion of sand should be just sufficient to produce cohesive concrete mix. A large number of tests are developed for the measurement of workability. Slump test, compacting factor test, VB test, slump test apparatus consists of truncated cone having 100 mm top diameter, 200 mm bottom diameter and 300 mm height. The slump cone is filled with concrete mix in 3 layers, compacting each layer with 25 standard strokes of tamping rod. The cone is lifted vertically without jerk and vertical subsidence of top concrete surface is measured from the original top face of the cone. Depending on the type of concrete mix, the slump may be true slump, shear slump or collapse slump. The slump test is ineffective for mixes of very low and very high workability. Compacting factor test was evolved to relate the external work applied to the internal work required for compaction. This test is very useful, especially in dry mixes. The workability as the degree of compaction is expressed in terms of fraction obtained by dividing the observed weight of concrete allowed to fall in the standard cylinder through a standard height by the weight of concrete. Compacting factor is equal to Ws minus Wo divided by Wf minus WO. Here, WO is the weight of empty cylinder, WS is the weight of cylinder and concrete with standard compaction. WF is the weight of cylinder and concrete with full compaction. VB apparatus test is based on remolding time in seconds of a conical concrete mold to cylindrical mold in a standard vibrating apparatus. The time measured in seconds required to convert conical concrete mold to cylindrical concrete mold vibrated in a standard VB apparatus. VB test becomes ineffective for very wet concrete mixes. Ranges of workability of concrete with respect to placing conditions. Concreting of small sections with vibration. Workability very low. VB time 20 to 10 seconds. Compacting factor 0.75 to 0.80. Concreting of light RCC section with vibration. Workability low. VB time 10 to 5 seconds, compacting factor 0.80 to 0.85. Concreting of light RCC section without vibration. Workability medium, VB time 5 to 2 seconds, compacting factor 0.85 to 0.92, slump 25 to 75 millimeter. Concreting of heavy RCC section without vibration. Workability high, VB time 0 to 2 seconds, compacting factor more than 0.92, slump 75 to 125 millimeter. For smaller size aggregates, the slump value will be lower. Factors affecting choice of workability are: greater the size of the structural element, lesser is the required degree of workability. Narrower the section, higher is the degree of workability required. Higher the reinforcement, higher is the degree of workability required. Where compacting is difficult and done manually, higher degree of workability is required. Workability is defined as the measure of useful internal work required for full compaction of concrete. Workability property of cement concrete in its plastic stage plays very important role in molding and compaction, which in turn influences the strength of hardened concrete. Workability of cement is affected by the quantity of water, size, shape, and grading of aggregate. Depending on its degree, workability of cement concrete can be measured in terms of slump in millimeter, compacting factor as fraction, or VB degree in seconds. Workability of cement concrete mix should be chosen on the basis of placing conditions, size and type of structural member and method of its compaction.